Hello students, welcome again to chemistry channel, and again we have to start with online teaching and learning. So we are starting with the unit number 8, that is redox reaction. Already two definitions of oxidation and reduction I have taught in college, okay, but let us revise once again and start from the beginning. Okay, so the weightage is already given to you, and this is the day-to-day's example. When you cut the apple, it becomes brownish. So this is the good example of redox reaction. Okay, I hope you understand who am I. I am Mrs. Anjali Nadgouda, Department of Chemistry, KLS Gokte PU College, Belagavi. So what is oxidation? Addition of oxygen or electronegative element to a substance, or removal of hydrogen or electropositive element from a substance. These definitions are already we have learned about the oxidation and reduction. So the simple definition which we can remember is loss of electron is oxidation, that is LEO, and gain of electron is reduction, GER, gear. Okay, so let us move further. This is an example, pictorial example of what is meant by oxidation and reduction. So one atom which is electron donor, which is giving the electron to the other atom, which is electron acceptor. So the electron donor is oxidized donor, and you can see that part is cut, means itself it get reduced. Okay, so this process, loss of electron, is oxidation, whereas the atom which gains the electron, that is reduction. Okay, then what is meant by redox reaction? The reaction in which both oxidation and reduction takes place simultaneously. Okay, in other terms, in electron transfer we can say that the reaction in which loss of electrons by one substance and gain of electrons by other substance, both these process takes place simultaneously, and hence it is called as redox reaction. Okay, then oxidant and reductant, that is oxidant, dant means oxidizing agent, reductant means agent, reducing agent. So a substance that can readily accept electrons from the other substance is called as oxidizing agent or oxidant. So oxidizing agents are electron acceptors, and the reductant is a substance that can readily lose the electrons to other substance is reducing agent or reductant. So reducing agent or reductants are electron donors. Okay, now if you see, so these two are opposite definitions. Now in this pictorial form you can identify A, that is compound A, loses the electron, right, to B, right, hence it acts as what? Reducing agent, right, and itself it gets oxidized, correct. So B is electron acceptor, gains electron, and hence it is oxidizing agent which itself get reduced. Okay, here one more example in day-to-day, the simple reaction. Twice Na, that is sodium in solid state, reacts with chlorine in gaseous form. Gives 2 NaCl, that is sodium chloride. To balance the equation we have written 2 NaCl. Okay, so here Na becomes positively charged and Cl becomes negatively charged, means Na loses the electrons and chlorine accepts the electron. Now here 2 atoms of chlorine are there, therefore 2 Cl minus means gain of 2 electron, whereas 2 Na, each Na loses 1 electron, as 2 Na are there, therefore loss of 2 electrons. So Na loses the electron and hence this is act as reducing agent, whereas chlorine accepts the electron, hence it acts as oxidizing agent. Okay, the loss of electron is called as oxidation, whereas gain of electron is called as reduction. Okay, now one more term, that is oxidation number or oxidation state. This reference has come in classification of elements and periodicity. Right, what is oxidation number? It is an apparent or real, that is actual charge on one atom in a compound. Okay, now in this topic we are going to learn how to calculate the oxidation number of an atom. So here are some rules for assigning the oxidation number. The oxidation number of an atom in the elemental state, that is uncombined state, is 0. Examples are given, that is oxidation number of Cl2H2O2. Now you may see that Cl2H2 means we have written in molecular form, but they are in free state, remember, or stable physical state. Okay, and hence its oxidation number is considered as 0. Okay, the second rule is the oxidation number of an ion is equal to its charge. Whatever charge we write on the top is its oxidation number. So example is oxidation number of Cl minus is -1, oxidation number of Mg plus 2 is +2. Okay. Third rule, the oxidation number of hydrogen in all its compounds is +1 except in active metal hydrides. So whenever it forms metal hydrides, it is -1. So here the examples are given. Metal hydride like sodium hydride NaH, it is -1. Then fourth rule, the oxidation number of oxygen in all its compounds is -2 except in peroxides it is -1 and in superoxides it is -half. Okay, so there are some exceptions also. Now here some examples are given. Now you may see even oxygen having +2 and +1 oxidation state whenever it combines with most electronegative element, that is fluorine. Okay, so in OF2 it is +2 and in O2F2 it is +1. When we are considering this oxidation number, it is for only one atom, remember, in any compound. Okay. Then in KO2, this is called as superoxide. Hydrogen peroxide, H2O2 is peroxide where it is -1 and KO2 is superoxide, it is -half. Okay. Then the oxidation number of halogen in their compounds is -1. Usually for all halogens we are taking -1. But even in interhalogen compounds of, remember the word, see here, interhalogen compounds of ClBrI gets even the ClBrI, it gets even positive oxidation state. It depends on what? The most electronegative element which is present with them. Okay, so in this we know that fluorine is having only one oxidation state, that is -1. Okay, but all other elements in their group, that is chlorine, bromine, iodine, even they show the positive oxidation state. In which type of compounds? In interhalogen compounds, that is the compounds which are formed with 2 or more halogens. Okay. Now in this, who is getting minus oxidation state? The one who is most electronegative element, okay, among them. So example, BrCl3, oxidation number of Cl is -1 and that of Br is +3. So here how we can remember this? The one which comes at the end in the formula becomes negative, the one which comes at the beginning it becomes positive. Okay, so this is the simple method to remember. Now one more note is there, when Cl, Br and I combines with oxygen atom, that is in oxo acids and in oxo anions, halogens have even positive oxidation numbers. Okay, so which one it is, that we will see later on. Okay, till that you can remember just this rule. So now if you see this fifth rule, is there the concept of is there the reference of fluorine is given? No, because fluorine exhibits only one oxidation state, that is -1. Okay, Then the oxidation number of alkali metals, that is group 1 elements in their compounds, is +1, and that of alkaline earth metals, that is group 2 elements in their compounds, is +2. For example, oxidation number of K in KMnO4 is K comes in group 2 elements, K comes in group 1 elements, that is alkali metals, and hence it is +1 oxidation state, okay, or oxidation number. Now, how to calculate the oxidation number? For that, these two rules are important, rule number 7 and 8, okay. So up till now, that is up to rule number 6, we have seen the individual oxidation number. Now for calculation, what we have to use is given in 7 and 8. The algebraic sum of oxidation numbers of all the atoms present in one molecule of a compound is 0. Means if we consider a molecule, algebraic sum of the oxidation numbers, that is charges, is always equal to 0. Whereas the algebraic sum of the oxidation numbers of all the atoms present in the formula for a polyatomic ion, remember polyatomic ion, is equal to the charge on that ion, means it should not be considered as 0. Okay, and these two rules we will use for calculation of oxidation number. Okay, let us see an example of oxidation number in a compound. Okay, here one of the element or one of the atom will be underlined, and for that you have to calculate the oxidation number. Okay, so let us take the example of H2SO4. Here we should calculate the oxidation number of sulfur. So let us consider oxidation number of sulfur is X, that is unknown. Now oxidation number of hydrogen in all its compound is +1, except peroxide and superoxide, and in hydrides. Okay, otherwise we have to consider 1 only. So 2 atoms are there, 2 into +1 plus X, because we are doing algebraic sum, remember. Okay, plus oxidation number of oxygen is -2 in all its compounds, right? So 4 into -2, 4 is the number of atoms into -2 is the charge, or -2 is the oxidation number of oxygen, right? So 2 into +1 is 2 plus X and -8. Okay, so total hua 0. We have to consider the total as 0 because this is a molecule. H2SO4 is a molecule, and hence algebraic sum of the oxidation number of all the atoms should be considered as 0, or should be taken as 0. Hence X -8 plus 2 is -6. So X -6 is equal to 0, and X is equal to how much then? +6. Okay, so this is how you have to calculate the oxidation number. This question comes for 2 mark or even for 1 mark also. Okay, if it comes for 2 mark, then you have to do the calculation like this. If it comes for 1 mark, then you can write directly the answer with plus or minus sign. Remember this. Okay, then let us take another example, K2Cr2O7. In these 2 atoms are there, but when we are calculating the oxidation number, we should calculate only for 1 atom, remember. Okay, because as per the definition of oxidation number, it is the charge possessed by the 1 atom in a compound. So let us consider this is as X. So X be the oxidation number of Cr atom. 2 into +1. Now why +1 we have taken? This is for K. K is alkali metal and it is having +1 oxidation state. Plus 2 into X, because 2 atoms are there. Plus 7 into -2. -2 is of oxygen. So 7 into -2 is -14. The sum should be equal to 0. Okay. So 2 into +1 is 2 plus 2x minus 14. 7 into -2 is -14. Therefore -14 plus 2 is -12. 2x minus 12 is equal to 0. Therefore x is equal to what? +6. Okay, now this +6 is of individual Cr atom, that is chromium atom. Okay, this is how you have to solve. Now calculation of oxidation number in an ion, how we can calculate? The same method is there, only instead of taking the total as 0, we have to take it as the charge on that polyatomic ion. Okay, now why it is called as polyatomic? Because it contains more than 2 atoms. Okay, therefore it is called as polyatomic ions. Now here underline atom is Mn. So Mn is considered as X plus 4 into minus 2. Why? Because oxygen is having minus 2 charge, is equal to, the charge is given on the polyatomic ion is minus 1. Okay, 1 minus sign is there, means minus 1. So X minus 8 is equal to minus 1, therefore X is equal to plus 7. Like this CO3 minus 2. So here underlined atom is carbon. So let us consider oxidation number of carbon is X. So X plus 3 into number of atoms are 3. Which atoms? Oxygen atoms. So oxygen charge is minus 2. 3 into minus 2 is minus 6 is equal to, what is the charge on this? Charge is minus 2. Therefore we have taken the total as minus 2. So X minus 6 is equal to minus 2. Hence X is equal to plus 4. Okay. So here I have shown both one. You can just go through it, read it properly and do the calculations once again. I am giving you the exercise in next slide and try to solve the oxidation number of underlined atom. Okay. Both ions are there as well as molecules are there. Okay. Thank you. Let us stop it here. In next class we will study how to write the stock notation and how to balance the equations. Okay, or the type of oxidation redox reactions. Thank you.